Hello everybody, thank you so much for the opportunity here to talk about event sourcing. And we are also lucky to have Eric here because Eric and I used to work together and we built a system using event sourcing which is still running out there and serving the needs of the customers. We had fun together, so if there are any questions, if I can answer them, Eric will also happy to take a stab at that. But really, let's open up the presentation here. Event sourcing using Marten. Before I get started, I just wanted to understand how many of you are familiar with event sourcing, just familiar, have heard about it and knows what it is, not implemented. And how many of you have implemented it? Okay, that helps. And anyone familiar with Marten? Okay, all right, that gives me an idea of, and again, my goal today is to basically talk about event sourcing basics mostly, and also see with an example like how it is done in the code. So using Marten, so it would be half of the presentation and then we'll go into the code and see it running and doing event sourcing there and using seeing the benefits of it basically. So so what I'm going to do is I'm going to talk about how we traditionally developed applications, let's say 4 or 5 years ago when there was no event sourcing boom, but then the normal CRUD based application how we developed, we always worried about the state of the application, the end state. So CRUD operations basically modify that state, either read or update the state, and that's what the final thing what our applications were worried about, and that's what we coded for. And that's what I mean by application state. So we were really not worried about what caused the change, but really what the change is. So for example, let's say we are storing the address of a customer, right? And if there is a request to update the address of the customer, we would traditionally what we have done is updated the address from A to B, and then B is the final state that we have, and then if customer moves to C, we update it to C. But then if business comes back and asks us where this customer used to live before, well, that wasn't a requirement, right? That is what our answer to the business is. Okay, that's a new requirement. Now we'll record where he lived before. But so far we were recording what is the final state in the the application final state basically in the address.
So are you saving that data somewhere where you can go back to it or not before that request? Were you backing it up or archiving it or anything?
So unless you plan for it, right? Unless you plan for it, if I as an engineer already know that this is something business might ask, probably I would plan to store the previous addresses, but naturally I didn't think about it, right, in the initial days, and requirements change. So my system that is CRUD based now, where I'm storing the application state, is not that adaptable, right, to change. So this is one problem statement which event sourcing tries to address, and naturally by design we'll see it how. Also, yeah, this is pretty much what I said, where it's hard to know what really caused the state change, because our intention was to update the spinal change, but really not capturing the cause of the change, right? So that's why it's always hard from domain perspective to understand really what caused the change in the address, like for that example, because customer moved, or was there any other fact because of that it happened, right? Also, we have other challenges like in the CRUD-based system where, unless you plan for it, the scalability of it becomes limited over the period of time, because traditionally what we have seen is now, again, I'm talking 4 or 5 years before traditional 10 years of span where we had the relational database, SQL databases, and then the application is kind of talking to a relational database, saving, querying, and then if the relations grow, your queries joins grow, and then your query starts becoming slower and slower, and everything is stored in a single database, and initially it starts that way, and then as we grow, the same database grows, and then your application kind of eventually starts running slower and slower and slower, right? So I think that's what the next slide also talks about here. So you'll find because you are updating the same item, you are querying the same item, you'll find concurrency issues if you want to go scale, and so all those things will be there, which event sourcing kind of tries to address a lot of it, like naturally. Also, as I was saying, unless you plan for an auditing mechanism, there wouldn't be an auditing mechanism. The product has to realize this, that there would be auditing needs upfront, and then they have to basically communicate that. Otherwise, it is not there. Like the history is lost.
I asked that because of our company, it is a requirement for auditing and life insurance, so we have to do it.
Gotcha. Yeah, some industries like financial insurance, yeah, they need it as a requirement. But some businesses and some domains don't really realize, like if at least, I wouldn't say don't realize, but it is not discovered in the domain upfront that there would be need of historical information down the road.
Reactive,
Yeah. So that's what event sourcing tries to address. Before I go and talk about what event sourcing is and go into the detail of it, I want to talk about go into a little bit technical direction here, where want to talk about CQRS. How many of you have heard about it and know about it? CQRS. Okay. CQRS is command query responsibility segregation. That means command means you are updating the state, like for example the address. So if you wanted to update the address, that's the command. Querying is reading the address. Now these two operations, when we separate them by design, like when we do the design of a system, when we separate these two, that's where you do the segregation between these two, like you're separating them. And the reason behind that, why you do that, is basically to gain the performance scalability as well as security is also a point there, and then allow the systems to evolve over time. So in the previous example I was saying that RDBMS, everything going in together, if we separate the read side and the write side, write operations and read operations for it, we would be able to think in that terms. So for example, for read side, you might choose a different database, which is effective and performant enough to give you that performance for your queries, right? Versus the right side, which is good at basically some relational databases where you can basically good at writing and storing your model and all. So you can think you could take that direction for your application if you implement this principle. So why I talked about CQRS? Because event sourcing is based on CQRS. In event sourcing, we naturally separate the writing and the reading part. That's why we talk about CQRS here. So, yeah, what is event sourcing? Really, it's a natural English here. We source the events if you talk about technically, we source the events in an append-only store. So, for example, as the event happen, we just capture the event and store it in an append-only store. So, why append-only store? Because append-only is the fastest way of capturing information. So insert operation, update operation, more than that, append operation is the fastest one. That's why the stores, the databases which are serving the event sourcing needs are mostly, they append. I think they are append only stores. So what we do in event sourcing is basically source the events which are, the sequence of events to basically capture the truth that happened. So for example, our life is full of events, right? From beginning to end. Whatever happens, imagine that as an event. Me entering the door is an event. Me having a pizza is an event. Right? So you're basically sequentially capturing all the activities as an events, and then you're basically storing them into a database. That's your right. That's it. That's your right side. So if you think about it, it actually naturally forces you to think your domain in terms of events, and that's how you talk about your domain naturally, right? Like if you're talking about trucks, right? So truck arrived, truck loaded, pallet loaded, right? Those are the events that happen, and then on those events, what should happen? Let's decide that later. First, capture those events, right? So you're naturally discovering your domain and in terms of events, and then you're defining the events, and then you're planning to store them. That's the source of truth. And this exercise is called as event storming as well, like where you connect with your domain experts and business people, and then basically talk about the domain and then the events in the domain, and then think about storing them. So so far whatever I was talking about, this diagram I created it, so not very pretty, but tries to capture the idea. Event sourcing basically can have, it's a pattern, so you can have many implementations of it, right? So in this diagram, I may not capture all of the implementation of it, but really the basic idea of what it is. So on the left hand side, if you see, again my left, and I think your left as well, yep. So domain events, so these are the events that I was talking about. In the domain, the events that are happening, you're capturing them. You're basically storing it in a database, and that database is called, in event sourcing world, event store, where you store the events sequentially, one after the other. So there is a system, you might have this process running which captures the event and stores them into the event store. Now this can be anything based on your needs. It can be a normal Kafka consumer consuming the events. If your events are receiving via the Kafka topic, or anyway, like if it's an API, in this example we'll have an API basically to have it simpler, to make it simpler. But then wherever the events are coming from for your domain, you're going to be listening to them and then storing it into the event store, one after the other. And then you will have to make sense out of this event. Now we have stored all the events. Now what next? How do I address the needs of the business with this information in the event store? So basically for that, you will have other smaller services which would basically read these events sequentially and try to make sense out of those events. create a state for the application. So for example, address changed happened from A to B, and then when we read the events, the first event when the address changed of the customer from A to B, that event, and then the next event, so it will read the information from both and then finally decide what is the final address for the customer. So that would be your read side. You can choose to store the application state, or you can, like the read side, you can choose to store it, or you can store in a temporary memory, or whatever you want to do on the read side. It's our choice, but the important point here is that you're separating the writing and the reading. Now here, when we try to read these messages, you can either use push or pull based mechanisms. In Marten, they do the pull based mechanism where they query the event store directly, and then you have your read side generated from it. But the library is evolving. They might think that push based mechanism is what we'll use, but yeah, it's up to the community of Marten. Benefits of event sourcing, yeah, as I said, because now think about it, maintains audit trail automatically, because really you are running your business, you're making sense out of this event store, and anything that is happening in your domain is coming as an event to you. So naturally you'll have history automatically maintained, because first address change, then second, and then third, and then whatever. Nothing is going to escape naturally. So you are maintaining the audit automatically of what has happened. So it's by design that you will have the history, the source of truth with you. It addresses concurrency. Now it kind of reduces it to a great extent. You have the write side separate and the read side separate. Now you can scale horizontally your read side as much as you need. Your queries are simpler because you are targeting a specific state. So maybe you are projecting just an address, and then for that address, you might have 100,000 queries, and you can scale that service easily horizontally, right? So, and that does not disturb your write side at all, right? It's your read side, so it's just scaling, and write side is still entering the events as is into the event store. So, and there are a lot of other, and there are a lot of other things in the right side as well, like which allows us to deal with the concurrency. We'll talk about it as we go forward, and that increase the performance and scalability also. Those are the other benefits, natural benefits of event sourcing. In other systems, you will have to put efforts into the system. You have to plan, you have to design in order to gain these things, but these are some natural benefits of event sourcing. Maintains domain language. As I said, it forces you to think about your domain, think about events, and you naturally talk business language. Then there would, in your code actually, you'll write natural business language, which is, say ubiquitous language, we say, like wherein business and engineering comes together and they talk a uniform language wherein the meaning of the word is same to business and to engineers, because the system, like the technical systems here, are forcing you to think in terms of design, in terms of events. So that's where it maintains your domain language. So there would be you wouldn't see things which does not make sense in the code actually. Well, there would be, but then again, the chances of it would be less, depending upon easier and accurate historical debugging. Of course, nothing is in your system without a history. That's why it's accurate to debug the business. Business debugging, I would say, like domain debugging, is easier because you know what has happened, and then based on that you'll be able to reason about why I'm seeing certain issue, and you'd know why, because you know what happened when. And I think the third one here is the biggest benefit of event sourcing, wherein now I know that, hey, historically I'm maintaining history, something changed. Well, I can. Someone might argue that, well, I'll just log and in my normal application, and that will maintain the history. But will you be able to build the current state by building the logs? No, that's not possible. But event sourcing allows you to basically rebuild the state by replaying the events. You can go back, set your clock back to the first historical event, and then start reading all the events again, and then come to the final state and that's where you can build the the current state if you see any issues or anything like that. So that is the biggest benefit of event sourcing. One of the biggest. The other one is that you can also derive new states from the existing data. So historically, for example, business did not realize that they would need certain requirements in the future, and they come back to you and say, hey, 10 years ago we started a service or something happened, and because we want to capture all that data, and then we want to see really historically how we did. So you can go back, read all things, create that new state for the business, and satisfy the business. So not just what you are doing for the existing business, but then also new requirements you're able to fulfill that. So adaptability is there. Like it is very flexible to address the needs of the business. Very close to the domain, basically. Yeah, fulfills the analytical data requirements as well, right? The exact same thing I talked about. All right. So far, any questions there? Okay. So let's see benefits of event sourcing. Yeah, I think I'm here only. Sorry. When to use event sourcing? Yeah. So event sourcing. So what we have seen, like Eric would also agree that there is a learning curve to this. And the team needs to understand really the different parts. These are some points when when you see these symptoms, you should use event sourcing. Otherwise, try to stay away from it. But again, there are debates about it as well. And it's up to the industry. But these are some of the characteristics. If you see, then try to use event sourcing. You'll see tremendous benefit. When you have strong auditing requirements, this is the best pattern to use, basically. When you need to replay events, you should go, and then you need historical investigation abilities, or you want to see that if the flexibility to change accommodate the newer business requirements easily. So event sourcing is the way. Yep. And eventual consistency is acceptable. So eventual consistency is basically your state is consistent eventually. So because your right side and read side are different, when you make the change, there is another system you saw in that diagram that the read side is a separate one. So it reads and then projects it. What if that system crashes down, right? If there are issues with it, then your state is stale. You're not the current state because you have still more events to read. So you'll read that and then you'll apply that into the state. That's why you're eventually consistent, right? You're not consistent. So when you had, like in the relational databases, we say that we achieve strong consistency there because we write the data at the same time, and it's guaranteed that in the single transaction you will see that the data is updated, so it's consistent. But here, because you've designed the system that way, it will be eventually consistent. But in Marten, there are ways wherein you can achieve strong consistency as well. But event sourcing as a concept is based on eventual consistency. All right, what is Marten? Marten is in simpler terms, it's a library sitting on top of PostgreSQL. It allows you to talk to PostgreSQL, and reaps some of the benefits of PostgreSQL, like being fast and the JSON beast, allowing the JSON B as well. So it kind of reaps out the benefits of it as a document DB and event store. So we'll not talk about the document DB side of it a lot because I'm not that familiar with it, but event store, I worked on it, so I'll talk about that part. So what does Marten provide us? As I said, it's a library. It allows us to use PostgreSQL as our event store, and allows us to read those events from the event store and store it within the Postgres as JSON-B, so that whenever you are loading, whenever you're loading those documents that you've projected, it's fast, and also storing the event is also faster. So it has all the code in the library which allows you to do all this storing events, appending it, and then reading it, and then projecting it. So you don't have to do a lot. You just have to think about your domain, and then a few things here and there, just the setup, and then it allows you to do event sourcing easily. So far whatever I talked, except the part of Marten, I think if you Google about event sourcing, you'll find ton of information, mostly talking theoretically about this part which I just spoke. But then what we're going to do today is going to take a look into Marten's library, and then how, from coding, how can we basically implement this. So I'll speed up a little bit here. We talked about event. What an event is, everybody knows. It's a record of an action taken in the system. One of the characteristics I want to make sure that everybody knows about events is that events are immutable, that you cannot change them, right? So I entered the door, it is an event, it does not change. I cannot un-enter the door, right? So I either have to exit the door, which is the compensating, you can consider it as compensating event, but really it's another event, right? So events are immutable, like you cannot change them, and that's that's really important, because event sourcing is based on that concept, because you're sourcing the truth, you're noting any changes in the system. So that property of event itself kind of helps it. What is the projection? So when we are storing these events, the action of reading it for creating a particular information or document, let's say, is what projection is, the strategy for creating it. So I'll call it as a view, creating a view, or aggregate. I just want to make sure that we are familiar with these terms, because as we go into the code, you'll be able to relate them well. Aggregate is basically a kind of projection which gathers the data from multiple events to create a single read side view document. Stream, it's a sequential collection of related events, so to represent a single aggregate. So basically there could be multiple different types of events. You are collecting them, making a set of them. That's called the stream of event, which represents a particular type of aggregate. So aggregate means, let's say, a document that you want to create with. We'll see in the example as well what a stream is in the database. But then it's a collection of events that happens sequentially. When you read that, you can make sense out of it, like a final state of your application, and that is an aggregate basically. And then the collection of events is the stream.
Like an address aggregate.
Yeah, like an address aggregate. Yeah. So and address changed, customer moved, customer transferred. Anything can be different events that kind of cause the change in the address. So this sequence of those sequential collection of those events is like called as stream. Now these are Marten specific terminologies. Now, inline projection, I was telling that in Marten they allow you to have strong consistency as well. So is something called inline projection, wherein what they tried doing is they tried writing into the event store the events, and then also reading, like updating the read side view at the same time. They read it and then updated the read side as well, give in a single transaction basically, to give you that strong consistency. Then there's async projection. This is another type of projection wherein, let's say, you are writing and reading in a single transaction. If that is very costly for you, for example, you're running a web application and in your projections a lot of things are happening, probably it's taking time, so you want to run them separately in a service, in a microservice. You run it separately and you read the events, and these two, writing the event is a separate service and reading is a separate service. So async projections allows us to do that basically, and async projections are eventually consistent, so because both processes are separate. Live projections are, and I think this is the last one, after that we'll jump into the code. Live projections are when you don't want to store the state that you've generated. You've written into the event, you're quickly making sense out of it, but you're not saving that state that you have generated into database. So that is a live projection, like live, you're reading it live, and this is also where you would need strong consistency to use it. All right, time for demo. Any questions so far before I jump in to the code? Is it visible enough? So I'll go and let me know if it's not visible. I hope it is visible. Okay.
602, that makes me happy. they just released 6.0 and it was a big deal, so that's exciting.
Okay. Yeah, this is a sample though. Okay. So I have a web API here, and I'm not using Kafka or RabbitMQ or anything like that. So to make it simpler and save my time as well as everybody's, I created a web API wherein I have some endpoints from where we can pass on the events, and then those events will be stored in the event store. And then I have a get endpoint on the same same web API from where we'll query the read side. And to demonstrate async projections, I have a background service which we can run as well. So okay, let's look at the domain really quickly here. So in the domain, the application here is the concept. Again, I opened the Visual Studio, saw the normal weather controller, that weather forecast control that we get, and from there I started thinking, what can I do? And that's where I came up with the domain here, which is imaginary, which is wherein we see certain events on the planets. There are many planets. On the planets we see certain events like a cyclone or a glacier slide, or I think there is a volcano eruption, and then there are ships basically somewhere on the base station which would try to go at the planet where the volcanoes are erupted and try to help. So some idea. So if the ships are less than the ships landed on the planet are less than the volcano erupted, then the planet needs help. That's my final state, whether I want to know whether the planet needs help or not. And that's the simplest thing I could come up with as an imaginary domain to explain event sourcing. So I apologize if this is not sticking well, but that's the imaginary domain that we have today. So for that, you can see that I have created events, and you, as I was saying, events are they are immutable. So you can see only get properties are no set. You can only, when you create an instance of this event, you can only create it with the constructor there, and after that it's get only. They don't change once you create. So cyclone detected is one event, glacier slide is another, volcano erupted is another. These are the planet events. And then on ship side, like the ships which are helping the planets, ship landed is one event which we are interested in, and ship started is another. So ship starts from the base station and lands on the planet. So when it starts, it might have some starting miles on it, and then when it lands, the landing miles, and on the planet on which it landed. So there are two things we're interested in here. Like I think three things here we are interested in. So I have projection. Let's go into the projections. What are we trying to project? Let's look at read side. Really, what we want. I'll go to the application. We have projections here. So I want to know this information about planets. This is one requirement that I have. This is my state, final state that I want. Is that on a particular planet, how many volcanoes erupted, how many glaciers slide, and how many cyclones hit, and what's the idea of the planet here. The second requirement is on the ship side. I want to know the distance traveled on that particular trip for the ship. Like on each trip, I want to know the distance traveled and the total miles the ship traveled so far. It might go on one planet, then another planet, then another planet, and the planets visited. Which planets did it visit? That's the ship side of requirement. And the third is the planet help. Do I need? So I'm looking at the ships which are traveling onto these planets, and then the planet events happening. These are two different things happening. I want to combine these together, and then I want to make sense out of it. Hey, ship landed, volcanoes erupted. If the volcanoes erupted are more than the ship landed, then the planet needs help. So this is how I am deciding it. So this is the third final state that I'm looking for. So why I have three different? Because I wanted to show what the streams are. So ship travel is one stream of events where I'm tracking the movement of the ship. So ship started and ship landed are the two events that I'm interested in whenever I'm tracking the ship. So if you look at ship travel projection, I am interested only ship started and ship landed events. I'm capturing those events. And that is my stream. As I said, stream is a collection of events, sequence of events that you're collection together. When you read those in sequence, it makes sense to you. So that's the stream, right? So what sense I'm making here is the ship travel, this thing. This is the final aggregate that I'm looking for. And these are the two events in that stream. Another stream that I have is of planets. What's happening on planets? Cyclone detected, glacier slid, and volcano erupted. These are the events I'm interested when I'm talking about planets, and because I'm maintaining a count of what's happening. So that is another stream. So these are two different streams that we can project from the events. Now these are single stream. That's why these are called single stream projections. This is coming from Marten. So you're actually trying to project single streams. But what if I had to mix these two streams? That's where I have this planet help projection, wherein I'm saying that, hey, I'm interested in a planet event as well as a ship event. These are the two different events coming from two different streams. I want to make sense out of it. That's why I'm subscribing to basically these two events, and then streaming out of, projecting out of it. So those are called multi-stream projections, when you are trying to mix multiple streams and make sense out of it. So So far so good. This is how our projections are looking. We've looked at the events. Let's try to basically run the app here. Any questions so far though? No? Okay, good. Let me go ahead and probably delete this schema here. And one of the best things about Marten is that it recreates everything for you. So there's nothing in here right now. This is Postgres running on my local system, our applications database basically. That would act as event store as well as the read side as well, both the sides. So let me go ahead and start. Okay, so planet activities post. This is where I can post the planets. So let me go ahead and I already got some GUIDs, generated some GUIDs basically. Let's take the second one here. So let's say this is the planet we're talking about, and on this planet let's try out this is the planet's ID. The event name, let's say, is cyclone, or let's say volcano, because we want to do the multi-stream as well. Volcano erupted. Location north. Intensity high. I'm not gonna fill everything here, but let's see. And volcano is, cyclone is away from coast, so volcano is not. So I'll keep the correlation ID as is, and now you see it's loading and loading. The reason behind it is that, and it's successful, reason behind that is this is a first call. Marten detects that you have projections, you have events in your code, but hey, in the database I'm not seeing anything. I don't even see the schema you're talking about. So that's where Marten goes ahead and runs some SQL scripts behind the scene, and it creates this thing for you, the schema, in which you will see all the tables. Everything is there for you. So that's why the library, right? They are making our lives easier. We don't have to code all these things. This is the framework stuff we get from the library, and we can build on top of that. So I'll go through these tables and explain what they are. So empty underscore events is the table where our events are stored. That's acting as our event store. So if I go and query that database, that table, you'd see that it has that volcano erupted event that we just passed. So what I'm doing in the code behind the scene, I have that controller. If we go to that controller, where is that controller? Here we go, planet activities. On the post call, I'm just saying whatever we are getting in here, the planet activity that we passed in, the contract that we passed in, convert it into the event, nothing but just saying that hey, volcano erupted, instantiating that volcano erupted event class that we saw, and then I am just appending that to the event store. And this underscore session you see here is the document session that I get from Marten basically. So it is holding the context for you to interact with the database as you do an event, entity framework, right? So all I'm doing here is just appending and saving the change. This is the only write operation that happens. One more thing I'm telling here while appending, what is the stream ID? If you look at the argument of the method here, they are like, what's the stream ID? So stream ID is the planet ID. So I'm talking about a particular planet for which I want the information, and these are the events I'm subscribing. That's my stream ID. So the planet ID is the stream ID. So you're saving the changes, and that's what when you save it, that's what you're seeing in the event store here. So far so good. And this projection this projection, the planet projection, activity projection, this projection is an inline projection. So if I did talk about what an inline projection is, an async, right? Inline is the one which gives you the strong consistency. It saves your read side at the same time when it writes the events. So I have configured it as inline projection. That's why our read side also have updated. So if I go back into the database here, the read side are these doc tables that you see. So for planet activity, you would see that the read side is updated. So if I click on the data and see the JSON here, the JSON here is that, the total calamities, volcano eruption, the final state of the planet summary that I was interested in, right? So that got updated on the read side. So I'll go ahead and add in some more states here. So let's say on this planet we also had a ship, let's say one more volcano here. Okay, not go that way. Maybe let's go ahead and land a ship there. So let's go ahead and start a ship and then let the ship land on that planet. So I'm going to go ahead and take my GUIDs. Maybe I'll take one of the GUIDs here. These are normal GUIDs. I've just categorized it so that I can come back and remember what was what ID.
Great for demos.
So here we go. Ship ID, and then the landing planet ID. I think I had it copied, so I'll just paste it from Ditto. Starting miles is just starting. Landing miles, well, it's just starting. Oh, sorry, landing planet is starting. Sorry. So the status of it is started. So probably I'll keep the landing planet as null because it hasn't landed yet. So I'm just gonna keep it null. I'll use it for the landing event. So I'll execute this. So this was quick. We saw that this is in here. So I'll show it once I say the landing event, save the landing event as well in the database. Oh, sorry. So we say started at 0 and now let's say to travel 100,000 miles. Execute. There we go. It appended it. So let's go back. We're doing good on time, right? Okay. So ship started, ship landed. Both the events are in there, and you can see that here the event stream ID. So the first event stream was for planet, right? That was the planet event for the planet. The second event stream here is this 9CF that you see. That is the that is the ship's stream, and for that you can see that versions are increasing. So for this stream, this is the second version. That means you have a second event into that stream. And now let's go look at the ship travel document. That was my second projection where I was interested in knowing how much the ship has traveled and where it has traveled. So that's my state. So let's go ahead and look at that. Also this is also an inline projection that is also registered as an inline. So you would see that the final data in here, that ship had total miles 100,000, it traveled 100,000. So these two things happened. Now on this planet we have ship landed once, volcano has erupted once. So maybe this planet doesn't need help. How would we know that? That's our third projection. So let's go ahead and run that. That is the async projection basically. So I will go and go into the async projection in here. So you can see that the planet health projection is, I have configured it as async, so that means it would run as a separate service. Now you have all the events, it is going to read those events, make sense out of it, and project the data. So I'll show you so far in the docs you do not see any doc for planet help, right? Because we did not run the projection yet. So Marten is like, well, I don't know what you're talking about. But then when I run the async projection, then it will see that it's not there, and it will create that table and put the data in it. So let's go ahead and run the async projection. Set as startup. So there we go, it started, and so you see that, hopefully I can capture it. You can see that this is the script, SQL script it runs behind the scene. Hey, it detected that that table was not there, so you can see Marten empty doc planet help. It's going to create that table for us, and then store the data in it. The read side, it will update the read side. So if we go back into the database now, because now if I refresh it, we'll see that table. So you can see planet help table, and then view the table. So if you go look at the data, so help needed is false because ship landed, volcano erupted. Let's go ahead and we'll erupt another volcano, and then probably we'll see if that planet needs help. So for that we'll go back to our inline projections and run that API again. Alright, planet activities, and try it out. On that planet, I think it's stored in here. What is the planet ID? That's why I noted. I think we took the second one, right? The B3C. Okay. Sorry about that. B3C, event name, I think volcano erupted, and I'll just skip those. Okay, we should be good. So this is the second volcano. Now let's go back in the event and then go ahead and try to view the table, and you'd see it's not there yet. Why? Because we stopped the service, so we have to run, like that service has to be running behind the scene, right? So we stopped that service. So let's run that service, and it will read that. So that's an async projection, it's going to read it. So just set as startup, and then read it. So here you can see that in the logs, you see that it started from sequence 3, mark of 3. It's going to read that. I think it read it already. Okay.
Yeah.
Let's go ahead and query. No, it hasn't read it.
I think your swagger had ID with extra quotes.
What was that?
When you did your swagger, I think you had extra quotes on the plan ID.
Oh, this demo mistake.
I think it's the hardest part of these demos. Yeah.
Demos. I'm gonna stop this. I'll have to redo that. I'm gonna stop this. Set that as startup. And we are nearing end here, so we should be good spending time on this one a little bit.
So in that case, could you go back and you said they're mutable? Is there a way that you could go, like, while you're debugging, go fix that so it comes through the right way?
So the change was in ID. it was the data that was changed, right? So yeah, that in this case, let's see, what was that?
Good question.
Good question.
It sort of breaks the rules, the whole thing. but-
Yeah. That's what breaks the rules, and that's where you do, whenever this kind of thing happens, you do rebuilding the projections, and so let me refresh this. Let's see. Well, that event never entered
I think it's because of that extra.
because of that. The GUID was not correct, so
I
that.
saw a bad request exception. I wasn't sure if that was my
Yeah,
name.
exactly.
That was
I
the
didn't check it here. Yeah.
But looking now at
So this time, let's make sure we see that. So I'll make sure to be, and that's the ID. I'll just make sure the last is 96. Okay. Event name is volcano erupted, and we should be good. Let's see why it is taking a long time. Okay, so we are good. Let's see if the event has landed in the events table. We see the version 2 updating for the same stream, and this is the volcano eruption.
There are literal books written on that question you asked.
Okay.
And now let's go ahead and of course this is not, so I'm not going to query this, but let me query that again. So it's F5, the state is not up in here. We'll run the background service and then see, that would basically update it. And the high water mark should pick it up from the events in here. So you see 3 to 4, the sequence 3 to 4. So we should see, what's that, by the way? So if we go in here, look at the table, this is that sequence ID from 3 to 4. That's what the state where it is, like it
We didn't
starts.
have that login when we started it. Yeah, they added that login like in 4.0 or 5.0.
Okay. All right. So let's go and look at whether this planet needs help now. So it needs help because the volcano eruptions are 2, and then help needed. The ship landed is only 1. But anyways, that's how the read side gets updated. I'll quickly walk you through what these tables are and what this whole structure it creates, and then we might look into the tables as well here. We've extensively worked on this for 2 years. Again, after that I had a big gap, so I might have forgot things, but then still I'll give it a try, and we have Eric as well to help. So empty underscore events table, as I said, this is the one which acts as the event store, and then all your events are storing in that. Then the doc tables are the tables which are your end state, the read side of your application. That's where you read from. Empty underscore streams. So I did talk about what a stream is, right? So it does maintain information about those streams. So I have 2 streams. One is for the planets, one is for the ship. Those are the 2 streams here. And it also maintains like at what version those streams are. As you see the events after events, the version kind of keeps on increasing for the stream. And then this is kind of keep tracks of it. So all the streams in your application, it keeps track of the streams here. And there is a foreign key relationship with empty underscore events where you would see the stream ID as well. Empty underscore event progression. This table is specific to only async projections. So here it will maintain really where you are in the state of reading the events. So it says that planet help projection, which is the async projection, is at sequence number 4. So in empty underscore events, we saw that there are the sequence IDs. So this projection is up to date until that 4 sequence ID. So you can see that, if it is delaying, then this number would be behind. Like it would be, let's say if there are 10 events that you've received, but you see here 4 only, then you're actually lagging in terms of when you're reading. So that's when you want to look at your database Postgres and then see, increasing, bumping it up a little bit in terms of memory, CPU and all that, and give that power to it basically to go fetch the records there. One thing I did talk about is that in the events in the CQRS I was talking about, from infrastructure point, you can separate the read and write side, right? Write database is different, read side is also different. Really, until what depth you want to achieve in your architecture, it really depends on that. Marten is storing the read and write in the same database today, right? I'm not sure if we can separate out, but as far as I knew, we cannot actually.
They're in 6.0. So they have multi-tenancy, and now there's some capabilities there, including like different tenants.
Okay.
So they're working on it.
Okay. Yeah. It's a work in progress. Again, it's a community work. So yeah. But then with Marten, if you want to develop an event source-based application and you don't want to separate the infrastructure, I think it's a good one. We had at least 1.5 to 2 million events processing per day in the event store, and then we were projecting them out into 17 or 20 different services, 17 different projectors, and all of them were working really fine, and the data was also not less, it was a lot of data actually. So it worked well for us in that case actually, and we were paying very less for the PaaS offering from Azure on PostgreSQL. We were using flexible server. That worked out really well for us. I think I covered all of it, but then again, you see the indexes are already there, and then also it creates behind the scene the functions. Basically, these functions are being used when it wants to insert those events. When we did that append event, so behind the scene it invokes these functions, inserts into those empty underscore event table, and then also updates the read side database tables as well. So all these functions are in here. Any questions? Is it making sense, first of all? Is it okay? Am I doing a better job or not? Okay, all right.
I got a question for you. When if you had multiple consumers on your event queue, how do you synchronize those consumers so that they're not both picking up the same message, right? So you don't send the same message twice. Same event twice.
You're talking about event store in here, multiple consumers reading the same message, same event multiple times.
How do you keep that from happening?
Sorry?
How does that not happen? Because that would be bad, right?
Actually,
or is it the responsibility of the consumer to figure out that, hey, this event has already been handled, I don't need to do anything with it?
so that's something called leader election in Marten. I think they use leader election algorithm, I think, wherein you saw that in the async projection you were seeing high watermark as a message basically. So what happens is when you have multiple projectors running from the same event store, I think what it does is it keeps track of the sequence ID. One of them keeps the track of the sequence ID, and then that way everybody else knows how much they are lagging, and then how much they have to cover basically.
I have one consumer that's responsible for telling everybody else which message or which events have been processed or handled.
Yeah, and what's really cool, and I wish I could sound more professional if I could remember the name, but in Postgres there's built-in functionality to help with this, I don't want to call it locking mechanism because that's not right, but basically you're telling Postgres, hey, this is the leader, here's the other ones. So what's nice is that if there is a system failure, great, whatever, Postgres, your source of truth, right? Spin everything back up and over Zoom or shift who the leader is. So it's actually kind of cool that because this is where I get preachy about Postgres, because it has 30 years of maturity, they can leverage features like that to do these operations.
And yeah, that's why I think the choice was Postgres here mostly, like because of those reasons. It supports that performance and JSON-B specifically. That's why I think. Does that?
Yes.
Yep. Yeah.
Is there a UI to view these projections, or is like somebody like on the business side if they have to view the projections? Is there a UI for this, or?
No, I think we have to build a UI. So I have this document here loaded in, right? And I can basically query that. So I have a get controller too, like get endpoint at the controller too. So you can go to so there's this get method. What it does is just tell the ID, the stream ID, document ID for it. It's going to load that document. It's just that simple. You've done all the hard work. Now it's just pick that data, and then show it on your screen. No queries, big joins and all, right? It's a straight JSON-B that you've created, and then you show that document on your screen directly.
So we have to build on our own, like that.
We have to build our own UI for it.
There's competitors like Event Store DB, which Greg Young named Event Store because it's like Kleenex. It's a great name for a product. Event Store DB, because that's a more commercial grade and you can pay for their offerings, they have a built-in UI. But I would tell you the maintainers of this would say, hey, we take pull requests if you want to make.
Gotcha. Yeah. This is all community Event Store.
It would be nice. Yeah, I'd love for that.
Yeah. I took Greg Yang's classes when I started learning about event sourcing. Yeah, go ahead.
So kind of back to Matt's original question, and you had the bad food. Where does validation live in something like this? Like,
Good
where
question.
are you validating the data that's coming in from these events?
Yeah. So I think that was one of the concerns we also had, and I think that we said that we'll go validate the data as it tries to enter into the system on the right side itself. So as the data comes into your event store, I think that's a place where you again, it can vary from person to person or thing, but this is my opinion, is that as the data is entering, you're thinking in terms of domain, right? And that's where your events are, domain events are, you're making sense of the domain and creating those events, right? That's where you can validate them and then store the data in there. But then we had instances where we had to do the validation on the projection side as well, the read side as well. But yeah, the real life. Yeah.
Probably want those validations to be very fast.
Yep.
They can't be dependent upon other data. You can't go query databases to do that, right?
Exactly, that's the point. In the projections, like if you're having a lot of dependencies in your projection, external dependencies, like if you're querying something from somewhere, and if you put all that logic in your projections are going to be slower.
You could. We've seen it. You could do that.
So you could do that, but then, yeah, of course, it's going to bring your projections down, and then eventually consistence, we say that eventualism will increase there, and then it's like at some point it's like not acceptable. So what we did was tried putting whatever was, external dependencies before the event store, and then we made sense out of that data and created our own events, which kind of entered into the event store, and then from there onwards it's simple.
Yeah, with the life insurance domain, I worked in life insurance for 5 years, funny enough. Without getting into the domain too much, but you have underwriting making these decisions saying, hey, we can approve or not approve, or we'll give you this insurance, but you're going to pay $1,000 a month or $900 or $100, whatever. Ideally, they give you that good data, but what Sunil just mentioned is maybe there's a Kafka message or RabbitMQ message or SQS, whatever the heck you use, and that's like a contract between that upstream service and your downstream, you being the consumer, and you might need to map that, and maybe it's one-to-one, maybe it's not. Those are large discussions we have with ubiquitous language, but maybe you should map it to your own internal one. Like your Kafka message shouldn't be the events you're storing. It might be one-to-one, but they're going to be separate objects because of a bunch of reasons. Sorry, there's like again like giant blogs, and I've seen giant talks about just these specific things because these are the gotchas or the discussions. Because we all have the experience of, hey, let's make a CRUD app, but like as it grows, there's little gotchas. Like we all have that experience, right? Same thing with event sourcing. You could add queries to your projectors. Maybe you need to create a solution the next week, otherwise the company's going under or something. Great. then do it. Great. But should you? That's me being on my little soapbox. So thanks.
Any more questions? I hope it made sense. My goal was to introduce you to event sourcing and give you a way to play with it and see, because in the industry they just talk about event sourcing theoretically, but there are very less presentations where they go and talk in depth about how to implement it. Of course, Jeremy has done a lot of these kind of demos where he has shown in various user groups how to do the Marten stuff, but we have done it, and that's where it's easier to show. Hopefully you can play around with it and learn about event sourcing and see if it fits your application. And I think I would suggest to definitely attend Eric's talk on event sourcing, because I'm sure now he has seen here and his presentation will be advanced a little bit, it would be a good natural follow-up to this session here. Thank you so much for your time and the opportunity to talk. I really appreciate and loved sharing what I could. Thank you.
Thanks.